Hey, y'all, let's go ahead and look at inverse variations with graphs and tables. I'm just going to go ahead and help you create the equation of the table that is there. So let's go ahead and understand what's happening in our word problem. It says a tuning fork vibrates particular frequency to make the sound of a note in a musical scale. If you strike a tuning fork and place it above a hollow tube, the vibrating tuning fork will cause the air inside the tube to vibrate, and the sound will get louder. Sky found that if you put one end of the tube in water and raise and lower it, the loudness will vary. She used a set of tuning forks and for each one recorded the tube length that made the loudest sound. So what you're going to see right there is we have our input right here, which is our frequency. We'll call this X, and then our output, which is going to be that tube length, Y. So let's go ahead. If you remember, in order to do a inverse variation, assuming it's an inverse variation, we're going to need to go ahead and find the value of X times Y, because these should be all the same and or close to the same for the inverse variation. So what we're going to do is plug this information into a table on Desmos and look at the graph. You'll notice I already have that there. But if you didn't know how to set up a table, it's really pretty easy in Desmos. You just go to the add item, add a table, and then you can start plugging that in. Now, the easy way to get that graph in so you can look at the data points is to actually come over here to this magnifying glass, zoom fit, and it will zoom directly into the data. Now, if you look at that data, you'll notice that it is not linear. It actually looks like it's making this little curve right here. And it actually is. So that tells us, since it's curving, it is more than likely an inverse variation rather than a direct variation. Remember, a direct variation is linear. So I'm going to go ahead. Let's go ahead and erase this. And we're going to go back to our table. And we're going to use those skills that we have. I'm going to look at that X times Y. So I'm going to come back up here. I'm going to see if they are all very close to each other or the same. So X1 times Y1. And what you'll notice is all the numbers are 37,000 and 200 and something, but they're all really, 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 really close to each other. And because they're really close to each other, right, in this column, I'm going to go ahead and see if I can model this data by finding the average of them. Because remember, what we're looking for is we're going to be finding our constant of proportionality K so that we can set up our inverse variation of f of X equals to K over X. So nice and easy to find the mean. I'm going to come down to cell 2. I'm going to type in mean. And what I'm going to do is I'm finding the mean of that X1, Y1. So I'm going to actually just type that in X1 times Y1. And that should give us that value of 37,227. So this, for right now, is what I'm going to guess or assume is our K value in that equation. So I'm going to type it in. I'm going to come over here into the next cell and see if it models our data. F of X equals to 37,227.1 divided by X. And if it overlaps our data, we're good. We have our inverse function. Okay, so let's go ahead and check that out. X, and check it out. It does overlap the data. And so that would verify that this is our inverse variation. And you can type that directly in and see and start making calculations with it. All right, y'all, hope that helps building inverse variations off of tables.